Yeah, thank you, Ron. And thank you all for coming today. Thank you all online for coming as well. And so like, as Ron mentioned, we're going to talk more about like, okay, we have these ideas. We have these sustainability goals, 2050, net zero. So now we're starting to allocate a lot of funding to be able to make these projects happen. But what does it look like to actually make a project happen? Like what actually is involved with, we have these ideas. And so what are the process to go, okay, we want to have a multi-megawatt solar farm provided for our utility that's going to be provided also by battery storage to provide power for us at nighttime. How do we make these projects happen? What are the variables actually putting these projects together to get implementation down? And so that's what part of the process that we do. Our job is to try to put these projects together. You know, we're in a very unique time where it's all of a sudden energy is combining with fintech, with financial operations, where all of a sudden now it's like lucrative investments for customers to invest into energy. You know, sometimes depending where you are, can be more lucrative than the stock market. And so we hear there's a lot of cryptocurrency aspects that are trying to do something called energy as a service, where they're providing energy for the public sectors, for certain regions within utilities. And so also, of course, now we're doing Internet of Things. And so there's one common denominator, that's energy. And of course, this new energy infrastructure world that we're all evolving to. So it's complicated processes. So we have, of course, our energy assets, you know, our production mechanisms. We can either have, you know, wind, solar, you know, fuel cells, but also the storage aspects. So storage aspects, of course, is controlling that energy. When are we going to use the energy? Because of course, sometimes, you know, with wind and solar, there's a little bit of variables out there. What's the temperature? What's the sunlight? What's the wind speed? So as there's many different variables that are coming outside of our projected ideology, then we're having some energy shortages. And that's where, of course, battery storage is going to be a huge technology moving forward to provide grid reliability and also sustainability for aspects of reliable resources. So a couple of things that are not the sexy part when it comes to energy projects is, okay, we have this technology, awesome. So now how do we do it? And how do we get it approved through certain AHJs, through certain projects? And so, of course, we have a solar panel. Solar panels are, when the sun is on, that thing is always on no matter what. So what happens when there's a fire or any kind of, you know, unforeseen problem that's happening, that thing's hot and energy is coming through it. Battery storage or kind of, you know, energy, you know, storage applications, stored energy. So if we can put two and two together, what is stored energy? You know, it's, if anything were to go wrong, of course, there's an issue there. But of course, there's many different safety precautions goes behind it. And of course, safety is number one. And these assets are all safe. But these are new technologies. So when we're submitting them to cities and plan checks, certain engineers that are out there that's responsible to pass these projects through, and also through fire codes and stuff like that, these are all newer. And so sometimes if we're not working with a trusted partner and a trusted company that knows how to get these projects approved, these engineers or fire code plan checks are just gonna go, I'm not touching that. And all of a sudden in the construction world, as we know, extra time means extra money that we're all losing, that we're essentially that is costing us penalties for this whole entire project. So it's very important to know exactly what we're providing, what we're submitting to the plan checks and to the engineers to make sure we have these assets and projects approved. And so I've been doing, Ron and I have been traveling around to a couple of places, and we've been doing a couple of different seminars, and a lot of what we hear is these new technologies. Okay, so I want to have a 1 megawatt charging station. So 1 megawatt charging station, now we can fill our cars, our electric vehicles up within under 1 minute. Because typically right now, it's mainly the mainstream high fast chargers now, like 150 kilowatt. And that's going to take around 5 to 10 minutes to charge our cars. So with that being said, now all of a sudden, before we have gas lines running through the utilities. So now, you know, being on the full supply chain aspect, how do we transfer electricity? How do we transfer power? We have to take away those gas lines, and we got to put copper. We got to put aluminum inside to transfer those electrons to the actual end user application. And so now something that wasn't foreseen, so we were in that market, the commodity market as well. So now all of a sudden, because of all this new electrification goals, there's copper shortages, there's aluminum shortages. And so now prices are being skyrocketed because of these different, it's a holistic, you know, a full big picture aspect of this whole electrification world. So it's very interesting. So right now in certain jurisdictions, some utilities have some issues, you know, providing power just right now without even considering EV charging stations. I mean, so let's say we go to a gas station, we have what, 10 gas pumps, maybe in the minimum. So now if we add, so we actually did a project for a transportation authority. It was 10 150 kilowatt charging stations for buses that we're doing in Orange County, California. And so now I need to design a system. So if all these buses are being charged right now, 10 times 150, that's 1.5 megawatts worth of power right now. And so do the utilities have 1.5 megawatts right now readily available? They're already increasing prices from 4 to 9 because there's already limitations and shortages that are going on. So there's many different aspects that need to be thought out about. And of course, I'm going to talk about battery storage later on in the presentation too. When we have battery storage, that battery storage is going to have the energy and power. We can use it whenever we want. So we don't have to rely on power demanded now where utilities go, oh my God, how are we going to be able to provide this? So that battery storage will have that energy and resources available to provide that instantaneously and right now. And something that I want to talk about, I hear it almost all the time, where, and again, back on the EV charging side of things and solar side of things, it's like, I want to have my EV charging stations be provided by solar energy, by clean green energy. So the smallest commercially available EV charging station is 50 kilowatts for fast drivers. It's a lot of solar panels to get 50 kilowatts. And so if we want to have, essentially a hub of charging infrastructure, we need to have at least 150 kilowatt charging stations with multiple at different sites. I want to provide it all by solar. And so we do large projects with different, ground mount opportunities and for specific, countries. So if you think about it, 1 acre equals 800 kilowatts of solar. So if we want to have, one charging station is 150 kilowatts, 2 of them, that's almost 25, that's almost a quarter of an acre just to provide power for 2 charging stations. So I'm trying to create some ideas and concepts of what actually goes into making these ideas and all these concepts to make a project happen. I'm not trying to be negative, but it's no, there's a lot of things that go into it, and it all can happen. It's just going to be a process to bring all these different aspects together as a whole holistic solution to become fully sustainable as an economy and as a society. So and so a lot of corporations and private companies, and also certain cities and jurisdictions have certain goals to become sustainable. Now there's all some chief sustainable officers are popping up with Fortune 500 companies. And so what we like to say is, if we're trying to become the most sustainable, the fastest and easiest way to do it is just change our power source away from fossil burning resources and have that be powered by clean green energy. And so by just doing those measures, we could almost get there by 90 to 100% of our sustainability goals by just transferring that power sources. As I mentioned before, there's a lot of holistically and that ecosystem that goes into it. There's a lot of factors at play, but it's the fastest and easiest way for us to do it. And so, we've been working with EPA and a couple other government agencies. The White House has allocated over $1.2 trillion for this whole electrification movement that we're going to be going on, clean green energy, EV charging infrastructure. Which is very surprising. We heard was, we have all this money. 1.2 trillion is quite a lot of money. And so far with what we heard, there hasn't really been, of course, but we're going to figure it out, but not necessarily specific plans on where this money is going to be allocated. And so as of right now, it's seemingly going to be allocated to the public sectors. And so I almost it's one of our initiatives that we want to, create is almost to create awareness to the private sector, to also create designs and concepts in order that they can plan and submit to the government to access this funding. Because essentially, if it's just going to be just the private sector, there's going to be some kind of imbalance. So all the logistic companies and trucking companies is not all owned by the government. And so that's going to have to be a full aspect coming together within the private sector and the public sector. So they're open to hear what are these design models to allocate some of that funding to these specific projects. But it's also for on us too to try to help create that awareness in order for private companies to happen. Because we work with companies all the time where it's, hey, do you want to go solar, battery storage? But at the end of the day, it's what's my ROI? Show me the money. If it makes sense, let's do it. The tax credit's going to reduce my investment by at least 30%. I can get a faster ROI, so let's do it. I mentioned about battery storage. It's a newer technology, but it's not a fad. It's here to stay. And so there's no coincidence that large-scale battery storage and EVs are just now becoming popular in the marketplace. It is the same exact technology. So as the EVs become more effective and efficient, the longer range times that we have, it's going to be the same aspect of large scale storage. So it's very interesting when we do our designs and when we're sizing specific battery systems. It's kind of the same design as we're designing. Let's say this truck needs to be out within 2 hours and 56 minutes. We need a 150 kilowatt charging station for that. It's a similar design when it comes to the actual vehicles compared to the storage infrastructure for utilities and different like subdivisions and more throughout public society essentially. And so this market is here to stay. So battery storage, as I mentioned, controlled power. So right now we have solar. So what happens when the weather is not necessarily consistent as we would like? What happens if all of a sudden there's irregularities? There we go. Voltage disruptions inside the grid and the facility. So now battery storage gives us that constant demand of power that we all can rely on in specific sectors. So, and I get asked almost every single time. So what are we going to do about recycling for batteries? It's brand new. We don't quite know yet, but the EPA has mentioned that they are going to put some funding programs available to promote battery recycling to make it more effective and cleaner way of recycling. As we know when we're watching TV, AA batteries are bad to throw away and it could be very harmful. So it is a very important topic. Okay. We're going to talk about more about, of course, we're going to talk about who our company is, what we mainly do, means of collaboration, potentially of how we can implement specific projects within, a couple of our company goals or city goals or utility goals. Dive into what is a microgrid. There's many different aspects of a microgrid, and we're going to talk about more specifics within that. And I'm going to kind of go over like a mock energy project. Let's say I have this hotel and this hotel wants to be totally clean green energy. What does that look like? What are the step process to be able to make that happen? And then if we have some more time if I have some extra time, we'll talk about more on the product standpoint to kind of show some options of what our different EV chargers look like. What do batteries look like? And we'll kind of dive into that from more of a visual standpoint. Okay, so what we do is we're a state-of-the-art energy department. What that means is essentially it's at core, we're a large-scale distributor. So we have access to the hardwares and the softwares to allow all these different technologies to come together to create this energy infrastructure for our projects. So the idea is to become a whole one-stop shop solution provider. And so that's where we're very unique. Our competition sometimes is mainly strictly one company, but they also are manufacturers. And so they'll only try to spec in their specific product, and that's essentially it. So for us, all we care about is to have a great project. We just want to. Every project is different. Like this hotel has a different energy portfolio than the building next to it, has different needs and different designs. So it's very important to specify specific manufacturers for those certain projects. And of course, there's different energy portfolios, different needs, and all that is extremely important. So over like last year, we did over, I think it went up to 90 million energy projects. And so we've been winning a couple of awards. Yeah, I had this little article that I wrote about how can you create a one-stop solution partner for energy projects. And then to create a little credibility. And so as Ron mentioned, we're a global company. We work all over the country. We have many different operating companies throughout different specific regions. However, we do projects, like I mentioned, all over the world, all over the country. So there's no specific area where we can only do business, and that's potentially it. We have local presence in Orange County and also many different areas in New York. So past projects all include universities. One of my favorites, a winery. Ron mentioned about fire codes out in California, and so this one, I don't know if you guys anyone like Cabernets, Paso Robles Cabernets. Maybe got shaking their head. That's one of my favorites as well. So hey, got to turn business into fun. And so during fire codes, the utilities can turn off. So in California, if there's any fire endangerment, the utilities can turn off power whenever they want. And so if you're a manufacturing facility, if you're a brewery, if you're a winery, you need constant temperature. And all of a sudden, it's fire hazards. You have no power. It's critical and crucial for your batches. And so what we did in Paso Robles, they had like this large scale facility where they're fermenting their wines. And so we designed a microgrid with the solar and battery setup. So in case there's a fire code or the power is shut off, that wine is still going to be fermenting or some of that great rich flavor of the Paso Robles Cabernets. Worked with transportation authorities, school districts. A lot of school districts are starting to implement battery storage technologies for their power demand from around 4 to 9 o'clock, but also in case of backup power for any type of grid instabilities. There's many different niches in the energy world. If it's strictly just, a lot of commercial property and industrial manufacturing is more from a ROI standpoint, as an investment standpoint. But different verticals have different needs and different projects has different applications. And so a lot of the technologies that we incorporate, and mainly that we see as more of the predominant ones in this energy world as of right now. Of course, lighting, let's reduce the energy footprint to make it as energy efficient as possible. And then once we have it more energy efficient, let's redesign it to be powered by clean green energy. So of course, once there's efficiency already going on, it's a much less, it's a much cheaper investment to design this energy production infrastructure. We have microgrid technology, HVAC. So there's a lot of energy efficient HVAC systems that are coming out to the marketplace. However, if it's something where I want to buy new HVAC for a fast payback, that usually is not the main part of that. But if we need new HVAC systems, might as well buy a new ones that are energy efficient. If it's mainly a payback scenario, it's going to be around 10 to 15 years, just on a financial analysis from the HVAC, from the heating, ventilation, and air conditioning aspect. For those who don't know HVAC, EV charging solutions, engineering, commercial industrial battery storage, financing, which is also very important, carports, and rebate consulting and management. And it's so important about what rebates are available in the specific markets. Because sometimes if you have an energy system, the rebates are for specific sizes and designs. And so if you're going into a project thinking, hey, I have all this money coming to me because of this rebate I'm going to be getting, that's not necessarily true unless it's designed to the specifications of that rebate. So it's very important to know exactly what is the funding that's available, make sure we're designing it appropriately so we can get that money that we're expected to reduce our cost of investments. So what this looks like from a design build aspect. So this is kind of an example of like a rooftop solar project. And it's important to know, okay, now what does it look like on a rooftop? A lot of local AHJs have their certain codes. Some have different, setbacks that you need for the roof. So it's like providing solar systems, but also accessibility to what's on that rooftop. And also from a safety mechanism too. So there has to be pathways where someone can get up there and have full access to every asset or asset of interest on top of that rooftop. So certain ASJs have specific walkway requirements that is needed, and also from a setback from the rooftop. And so it's important to work with a firm. This is not necessarily a selling point. This is very true. So if whoever we're hiring to do the design and modeling, of course, is going to go into and decide, how much power do we need to have to offset our power needs, or also to give us the power that we need essentially to have an operation that is up and running. But then, of course, that same firm is going to tie it to the economic aspect. And so they're going to go, because we're designing it in this way, here's your expected returns. And so, of course, it's very important to have a reliable, trusted partner that knows how to do it, because a lot of that project is based upon what that information is being provided. If there's anything wrong, we talk about the lawsuits. Lawsuits will happen, and no one wants to get into a lawsuit. And we went over this consulting mainly. What is consulting that we do? It's designing specific sizes for certain applications. And of course, designing the economic returns and implications behind these specific applications. So we'll have a project where a city wants to have their library be completely carbon neutral. So we have to go into these libraries. Okay, so what do we have? We have gas stoves in there. So now we need to go into that facility, retrofit all of their gas applications into electric, and then redesign a whole solar and battery system. So the consulting aspect of consulting can be spun in so many different ways. So mainly, I'd say is recommending specific sizes that are appropriate to each facility and bringing the economics behind it. And it's cool too on the EV charging fleet design aspect too. It's very important to know if we have fleets or specific, school buses that was mentioned earlier. So how long do I need to charge before that bus and that truck can get back up and running? So we can do that modeling for our customers as well. There's a couple of like cool past project pictures that I wanted to show. One on the left is one of our customers. He wanted to have the city to have the largest fast charging project in the country. So we're able to design and procure that for him and manage that project. And then a utility was, it's a pilot project. And this is in, I can keep it vague. It's in California. And they wanted to have a certain part of the utility be powered by solar and battery storage for that whole region, which is a pretty cool and fascinating project. Okay, microgrid. So what is a microgrid? We hear different aspects of it. Just because we have solar and battery doesn't mean we immediately have a microgrid. So I could define it as a microgrid is to essentially have a grid in a centralized location. Before, we have, there's power producing plants in the middle of, in the country or in certain locations. Now a microgrid is I can have a power production plant right where I want it and have my power resources and reserves. So this gives the energy independence and flexibility to, to whoever needs it essentially. And so two kinds, mainly vaguely, that I like to, to summarize it as. One is grid tied. And so one is still tied to the grid. You can have wind, you can have solar, you can have battery storage and also be tied to the grid. So this is more of an ecosystem that is working hand in hand with each other, depending on, so a lot of the Internet of Things comes into play where it goes, what's the cost of utility power right now? What's the cost of the solar power right now? What's the cost of the battery storage power right now? And so it's an interchangeable network to see what's the cheapest form of power, but also having infrastructure that's ready to be used at any given time. And so typically those are much more, it's not as, it's a faster return compared to a islandable microgrid. And so an islandable microgrid is, I don't want to be connected to the utility whatsoever. I want to be completely independent, not rely on it. So this is obviously a lot more of it's more of a resiliency and reliability play. And so like when it comes to an actual design and actual project, we need to design battery storage that's being charged from solar just in that. So we need to have a big enough solar system to charge a battery to have the power for the full 24/7 operation. So that's going to be a lot more solar, a lot more battery storage. So it's a lot more heavy investment, but sometimes when you have critical loads, it's a necessity. I'm trying to talk about increased profitability. There's a lot of energy resiliency, reliability, and sustainability play. It shows that we're forward thinking, we're enhancing our brand image. And we talked about, natural disasters. Unfortunately, like I mentioned in the brief example, the California Public Utility Commission can turn off power whenever they want. So if you're a manufacturing facility that has critical loads or that relies on power at every given instance, it's very crucial to have power that you can rely on. And of course, we have tragedies that happen in New Orleans and Houston and Puerto Rico. And so when we have these floods that go on and hurricanes, power's out for days and sometimes weeks, and it cripples cities and cripples societies and hospitals. And so to have a microgrid or a energy resilient operation, mitigates all these risks and allows us to keep us up and running. And so, it's a lot of, it sounds really complicated, but if you break it down to energy producing assets that have similar communication protocols with different softwares, so you can have specific receptors onto these energy assets that all speak to a same, I don't want to get too nerdy, communication protocol. And so once everything has the same communication protocol, now we have Internet of Things. Now we have machines talking to one another. And so in general, it's wind, solar, battery storage, with all the same communication protocols and a correct software platform that can manage and control the different and commission the certain systems that we need for our goals every single day of our lives or for that facility. And so here's an example of a project to kind of show what it would look like from a graph standpoint. So the dark blue is the existing energy demand from the facility. So the light blue is just a solar system that we designed, but they also wanted to have battery storage. So from 4 to 9 o'clock, their energy prices were increasing by like almost over 3 times. And so what this looks like is light blue is a solar production. We oversized it to be able to charge the battery so that battery will have power at night. And then in gold, that's when the battery is releasing. And so the white line essentially that's the new demand. So as you can see, it's significant reduction with a solar and battery play. This was under 3-year payback for a solar and battery project. This was a hotel, a huge hotel that has a big, large restaurant. It's also a cattle farm as well. Financing. And so we had a question about, is it cheaper to finance or pay cash out of, for specific projects? It's specific is that, and this in our opinion, is how much cash is available and what are your financial goals? And what does that look like from 5 to 15 years? What type of cash flows do you want to be able to see? There's many different financing options and strategies that are available. So we always try to rely on, we have one that we like to prefer, where customers get to own the assets. So of course that increases the value of the real estate. We try to make it cash flow positive. And so what that means is the annual savings for that system is going to be much greater than the annual cost for that note. So that's how we're able to get cash flow positive. But the thing is, that's going to be stretched out for over 25 years. But you're not paying anything down. But you get to keep all the rebates and incentives as sheer cash immediately. So that's where when it comes down to the economics behind it, it can be very, very lucrative investments for customers. We're seeing that customers can almost make, easily 6 to 7 figures just in year one by doing an energy project. I mentioned before, it's very, important to, we've seen, a couple of our, there's options to use software platforms as a means of design. And we've seen a lot of holes with that. So we try to make sure we design everything by hand to ensure that we have an accurate representation of what this product's going to look like for our customers. Okay, so now we'll do a little mock opportunity. So let's just say like this hotel, we have a project with this hotel. So what does this look like to get this project started and to make this project happen? So, okay, hotel owner, what's our goals? Do we have any sustainability goals? Are we looking for a fast return on investment? Or are we looking for a microgrid? So let's just say the customer wants a fast return on investment. You go, okay, fast return on investment. So then we're going to do, all right, I need at least 1 year's worth of energy information and also a year's worth of 15-minute interval data. So now I know exactly, I need to know how much power you're using and when you're using it. And if there's specifically any factors that's going to affect your cost per usage, that's all going to be critical in our designs. So now I need to design a system that is going to essentially provide you enough power for what you're looking for, but also give you a fast return on investment to essentially offset. So I need to have a system that's going to be operating whenever you're using the most power, it's costing you the most. So now I have a system to provide the fastest return on investment. So we create that concept. We go, okay, Mr. Customer, this is what we got. We create that model. I showed that kind of rooftop overview, what that looks like. And so now I need to see, I have a system size in place, but I also need to make sure that I know where to put it and it's going to fit at the location. Sometimes I can go, I want to have a huge solar system, but it's a skyscraping building that's got a huge amount of energy cost, but I have a limited amount of roof space to use for solar. So I can have these great ideas, but I need to make sure the floor plan works for us to be able to place this energy system on it. And of course, it can structurally handle more weight on top of that facility. So once we created that, we have our design, we figured out what sizes we have. We decided that we know where to put it. We're going to be okay. Then we get to engineering and we stamp it for electrical engineering to make sure electrically it all makes sense. We have the capacity available. It's going to work. It's safe. And also structurally, like I said, to make sure the building and then essentially the parking lot, if we decide to use carports, are structurally sound. It's going to be safe structures that we're putting on top of or in our applications. And then once we have our engineering stamped and ready to go, now it's time to procure. Now it's time to procure our products. And what we'll do essentially is we'll bring the product, try to do a full one ship complete. So we can gather our solar supplies, we can gather our battery solutions, and make sure we try to have it all arrive at a time whenever our partnered labor is able to do the construction process to mitigate time and to get this project essentially up and running. And of course, we have our product. Now it's time to construct it with one of our labor partners. And then after, we have a safe, good, great project. And now it's time to get that money and the funding that we're hoping to receive based on the rebates, grants, and incentives after the project's completed. And of course, and then we'll be here for the entire time for post-project support. So this is kind of what it looks like. Here's like one energy design or one example of an energy bill for my customer. As you can see, they have almost 7 to 8 different metrics of when this utility is charging them for the power usage. So each one of these different columns has a different price or a different cost of demand of power that they're accumulating. So of course, I need to make sure I'm designing appropriately to whatever these metrics are for specific times to give an accurate economic detailed model after the fact. We talked about rebates, grants, and incentives. We mentioned how it's important now for the private sector to start creating these models. And so they can have this model and start presenting it to local officials to get the funding that's available within this $1.2 trillion of funding that's available. So that design aspect is a way for the government to go, okay, I like this. Now we'll give you, whatever that dollar amount is to help your project be successful. This is an example of just a kind of more of an ROI standpoint. This project was 3.2 million, and based on rebates and incentives, it got down to 1.8 million. Within 3 years, they were $34,000 cash flow positive. And within 5 years, they were 1.5 million cash flow positive. So that kind of shows how lucrative these investments are. Here's an example of, sometimes customers they go, hey, I want to have the highest wattage solar module out in the market. And that's what all they're focused on. But there's something that's very, unique where it's like, hey, if you have a high wattage solar module, the dimensions may be much bigger compared to a smaller solar module. And so sometimes if we're just speccing in a large solar module, we actually can get more power in more of a confined space by using a smaller module because it's more space efficient. So customers have brought that to us a couple of times, so we want the latest and greatest technology, but sometimes it's not the best for specific projects. Carports are fun. It's a totally different sector. A lot of like the energy and electrical are somewhat incongruous, but the carports is a different industry more because it's a structural aspect. It's more structural design and structural engineering. So when we have a carport project, you need to know certain different things. We need to know, of course, what the surface is. What's the geotechnical survey? What type of soil is the structures are going to be drilled into? So we know that structure is going to be sound. What are the potential wind hazards in that specific area to make sure we're going to have a sound structure? And of course, depending on certain locations and seismic calculations on the more for the West Coast aspect to ensure that we can put our cars, we can walk under it, and this thing is going to be safe and sturdy. Which is pretty cool that newer technology that's coming out where there's going to be like translucent solar panels, and so you can create different racking structures and carport structures and have everything just be like crystal clear as you're walking below it, which is going to be pretty cool, and also pretty cool for like rooftops and stuff. Ground mounts, of course, that's somewhat similar to a structural aspect as you're putting stuff into the ground to make sure it's going to be safe. Battery storage, I'm going to give into. Yep, a little more time.
Like 5 minutes.
5 minutes? Yeah, that's good. And so I just kind of want to go over, just kind of give you like a little look into what these products look like and the different options that are available. And so battery storage, as I mentioned, a couple of the different values. So of course, there's time of use, energy management. So for utilities or even just for the facilities, from 4 to 9 o'clock, it becomes a lot more challenging to demand power, and power is a lot more expensive. So batteries can be used during that time frame. There's also demand management. And so sometimes for the utilities and also the private sector, where we're demanding a lot of power during a specific time, we can control and commission the battery to release during high demand times to bring down the energy demand to have a flat, stable grid. Here's what it looks like. So if you kind of see like the picture below, it's essentially, if you imagine like I'm like 6'1", so like a 6-foot cabinet with like 3 feet wide, and you just put like different like battery trays and you just stack it up. And you just stack up all these trays and cabinets together, and you have to put it in a large scale container. You got to have HVAC, you got to have lighting, and so you can just put all of these cabinets inside of these systems, and then essentially, depending on the scale, you string them. You string these different the energy demand that is needed, and just connect all these containers together to get our 40 megawatt size projects for large utility scales. So it's full turnkey. You have to have HVAC equipment for it. You have to cool the battery systems. As we know, if our phone gets hot, it shuts down. So the same thing with these large scale storage systems. We got to have HVAC systems inside of it, but also the software aspect. The software, you're able to control and commission the battery and tell it what to do. I think I may have a picture for us. Do I? Yeah, and so for that software aspect, you have a meter at the panel level, and that panel level is going to have again, the communication protocol aspect. It's going to communicate to the energy management system, so the brain inside the battery. And so that's how you know, like, you commission the battery, you have a meter that's telling what the demand is or the energy situation is. And then out of the controls out of the battery, it tells the battery essentially what to do, depending on what the controlled variable is telling us of what the situation is for that battery to be able to deploy or to charge. It's very safe technology, as you see. I'm getting close. So lithium-iron phosphate is the new, or like I said, the most common technology that is being used currently right now. And as you see, it's most importantly, it's very safe. It has a long lifespan. Mainly, they degrade around 2% a year. So if we can try to model it like that, so it's not terrible. And in specific applications, you do need performance guarantees, and we can essentially help with that, where that's essentially a need. Very powerful. As we said, it really lasts pretty long. We went over this fleet design. So I want to show you just kind of pictures of different charging stations and what that looks like from a different outputs and charging times. So there's codes out there where if you just need a charging station that's cost effective, you don't necessarily need a screen and have all the bells and whistles, but certain codes, if customers are trying to upsell the cost of electricity, you have to have a screen on it. You have to say what the price is and also what the price per power is going to be. So customers, it's kind of more like a gas station. You can't they want everything to be measured and transparent. This is a great solution that comes with the bells and whistles, highly reliable, has the screen aspect. So screen and credit card readers are the codes that's going to be evolving that charging stations must have if people that own the charging stations want to make a revenue off electricity. So they want to go 14 cents, I want to charge it for 18 cents. Screen and credit card reader is going to be a must. Here's another aspect. This one's one of the more pricier EV level 2 charging stations. And so here's an example of what some fast chargers look like. So let's go start with one on the right. That's a 50 kilowatt charging station option. That's going to be somewhere around $35,000 to $40,000 a piece. And that will charge your car in 30 minutes to 1 hour, depending on the battery or how low your battery is. Skip one. Let's see. Yeah, and so now over the past year and a half, a new technology came out where fast chargers can charge 2 cars at once. Before, it was only 1 car at one given time. And so these ones, one of our common ones are the 120 kilowatts and 184 kilowatts. So how that works is 120 kilowatts, you're going to get 30 minutes, 20 minutes to 45 minutes of charging time. 180 kilowatts, you're going to get 15 minutes to 20 minutes, I'd say, charge time frame. And so, of course, with that, let's say a 180 kilowatt charging station, you have 2 cars pull up next to it, and it just divides by 2. So it's 90 kilowatts per charge to each vehicle. This is we have a couple of bus and fleet projects that they use more heavy duty infrastructure like this. There's a 150 kilowatt one on the left is a power cabinet, which is pretty cool for fleets because you can hook 3 buses up at one time, and it does sequential charging. So one bus gets a full charge, then it goes to the next bus, and then to the next bus. So when you're charging overnight, you don't have to have someone get out and try to change the different cords to 2 different buses essentially. And the pantographs are going to be pretty cool coming out in the future, where you get the metal come down, bus rolls up, and it connects to the metal on the bus and starts charging. Okay, software aspect, but I don't want to take up too much time, Ron. I know we got to get moving.